Hello everyone. Let's take a look at our next problem. What are the last two digits of the number which is formed by multiplying all the odd numbers from 1 to a million? Okay, so first thing that comes to my mind is it should be pretty easy to figure out what the last digit is, because I'm sure we'll probably enter into some kind of pattern. But the last two digits, again, there might be a pattern again. No, this is a question. This really boils down to multiplying numbers together and taking a mod by mod of 100. Will there be an easy way to do this? I think what I'm going to start with is just carrying out the product manually and seeing if a pattern comes out, and then trying to figure out how we can prove that that pattern continues. So it looks like we have some kind of pattern coming out here. Eventually, we keep alternating between 25 and 75 as the last two digits. I'm going to continue this just a couple more times, and then if it continues, we'll see if we can try and prove that this always holds. Yeah, it seems to continue here. So, and let's also try and figure out where the 25s turn into 75s. So they're coming in groups of 4. So an odd number, so we have something like each odd number can be written as 2n plus 1, and I want to write n as being n I want to divide them into groups of 4, where it seems like the first one that actually matters is this one, number 15. So how do I want to write that? Let me just think for a second here and try and get this into my head. So what I've shown here is that if my product at some point, the last two digits are 25, and then I multiply by the next two odd numbers. If I multiply by oh, these are not both odd. This is, oh goodness. Oh, wait, no, this is correct. No, it's not. No, it's not. Start again. So if my product so far ends in a 25, and then I multiply by the next two subsequent odd numbers, what do I end up getting? Okay, so I've shown that if I have 25 and multiply by two consecutive odd numbers, then mod 100, I end up with 75. And I'm sure if I do the same thing here, 75, and multiply by any two consecutive odd numbers, this will probably come out to 25, but let's just make sure. Yeah, so if I take this and mod by 100, I'm left with 25. So this pattern continues forever, and that's shown by this. If at any point the product ends in a 25, then multiplying by any two consecutive odd numbers will flip it to a 75. And then once you're at a 75, multiplying by any two consecutive odd numbers will flip it to a 25. So all we really need to do now is figure out, as this pattern continues all the way down to, just before a million, when this number is 999,999, are we at 25 or 75? So what's the easiest way to figure that out? Well, we just have to look at the last digit, right? Like, is that correct? No, that's not correct. No, because it's multiples of, it goes in groups of 4. Well, I guess we'd have to continue this pattern up to, the easiest would be to continue it up to 100. Because then, if we continue this up to 99, the product up to 99 would be the same as the product of all the odd numbers less than a million. But we can move down in multiples of 8 from this. So, in fact, if I just subtract 80 from this, I get to 19, and we're already in the pattern. Yeah, so what's the idea here? Okay, so 999,999 minus 19 is equal to 999,980. This, I'm hoping, is a multiple of 8. What? Oh, because wait a minute. Yeah, okay. Yeah, okay. I said something incorrect a little while ago. This will not, the answer we're looking for is going to be the opposite of the 1 for 99, because in my head I was sort of mixing up multiples of 8 and multiples of 4. 100 is not a multiple of 8, but 200 is a multiple of 8. So if we continue this pattern all the way down to 199, this is 1 less than a multiple of 8, namely, it is 1 less than 200. And the final number in the table we're looking for, 999,999, is also 1 less than a multiple of 8. And so this number will end, the product up to here will end in the same 2 digits as the product we're actually looking for. So what we should do is we should try and subtract a multiple of 8 from this to end up somewhere back in our list and just read off of there. Now I know that when I subtract 19, what do I want to say here? Well, let's just find a number in this list that differs from this by a multiple of 8. What is a multiple of 8? Close to... I'm just going to brute force this, whatever. Okay, so 31 works. This doesn't. 199 minus 31 is 168, which is equal to 8 times 21. Okay, so I know that these two numbers, 199 and 31, have to be in this sort of the same group in terms of the last two digits of the product. So 199 and 31, the products will both end in 25. And 999 minus 199 is also a multiple of 8. It's 8 times this. And so these two numbers also have to have the product has to end in the same two digits. So our answer is 25. Yeah. A little bit of a sloppy ending here. A little bit of a sloppy ending here, but recognizing the pattern and proving that that pattern continues was really the key to this one. Thanks for watching.